Working on my sprinklers today. I got all these water spots on my glasses.
Is auto supposed to just say 2 on the second option?
Yeah.
Okay. I was like, I don't remember this term.
Spelling error. So everybody did pretty good on that exercise 5.1. Well, let's get started. Boy, there's not many people. I've got a lot of people coming late. Micah, you're here. Oh, wait. There we go. Alessandra, Nicole.
On the last one, would those be in 2 different lines? Like, is that another line after the semicolon?
Yeah, that's whenever I put a semicolon. If you put a semicolon, you can put things on the same line.
Ah, okay.
Yeah. It's just because that, oh yeah, I gotta change that. Let me change this here. I'm displaying the wrong thing. Here we go. Whoops. Oh, there we go. Alright, yeah, let's get started. We've got a lot to cover if we can get through it. So this is right out of your quiz 8. All right, so yeah, let's take a look at the poll. I just have one poll, but this is right out of your quiz. The following uses a step in the slice to delete every other element from the entire list. Delete numbers. Remember, we have 2 colons there, and you can just try it. Just if I was you guys, I'd just type these things right into the interactive part of VS Code and try it out. So nobody's voting for that. So that looks true to me. You can use delete with a list forget that, auto, to remove the element at any valid index or the elements from any valid slice. Right, so that kind of looks true. Because we could say, if we had numbers, we were using numbers a lot yesterday. Numbers. And I think it was just like 3, 4, 5. So if I said delete numbers, and is this a list or a tuple?
List.
List, yeah. How come? Brackets? Square brackets, yeah. So if I said delete numbers sub 0, what would that delete? The one. Yeah, first one, because that the indices start at 0. And the indices are always integers, right? They're always whole numbers. So if I tried to say numbers, I think there was a question like this, 3.4. It doesn't know how to index into this list with a floating point number. Hey guys. Okay, so that's how you can delete. So that looks about right. The following deletes the list's first 2 elements. Delete 0 to 2. Remember, it's start and stop minus 1. So that would delete the first 2. So this is not false. This is true.
What? Thought that would delete the first 3. 0, 1, and 2.
No, remember it goes, if I say, this is bad. Goodness gracious. If I leave these pins open for a second, they dry up. So if I say delete numbers 0:2, remember this is the that's the start. Oops. And this is the stop, but it's minus 1. So that goes from 0 to 1, right? So it would delete 0 and 1, the first two elements. All right, so this one's actually true. So that leaves this last one. The following code creates a list, then uses delete to remove its last element. So we say numbers equals list. And I don't know if I showed you guys, you could do this too. You could say numbers, there's a list function equals list. I can convert range into a list. And what was that again? Range 0 to 10. So that creates 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm saying delete numbers sub 1. Right? So this is going to be numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is numbers sub 1? These are, the indices are the same as the values in this case. So if I say delete numbers sub 1, what does that do? Which one's it going to delete?
Number 1.
1, yeah, it's going to delete this one right here. How would I delete the last value?
-1?
Yeah, -1. That's the negative. If I want to delete the 9, I would say delete numbers sub -1. That's how you go in reverse, remember? So this is also -1. You could refer to it as -2, -3, -4. These are all still whole numbers. So this is the one that's false. When you see that on the quiz, okay? There's probably some people that need to get in here. All right. Okay. Did we get? We didn't get everybody yet. Okay. So let's go back to my laptop. Hey, Cipriano, Karen. There we go, cool. Do we need to, before we start, do we need to review any of these up here, where we're at? Does anyone want to kind of go over any of these, or do you guys feel pretty comfortable about these here? Is there any that are kind of confusing to you?
Those are from the exercises.
These are the things that you turned in Tuesday night at midnight. Everybody's pretty clear about everything? Some people were saying the wrong thing. They were saying, like, what is number 9? What does index 10 do? If I say numbers is this list, and then I say numbers.index 10. Anybody remember what that does? Does this give me the value at index 10? Or does this search for the number 10 in this list?
It's such a fun number.
Yeah. 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 And if it finds it, it returns its index.
Yeah.
That makes sense? Okay. This will extend a list, but it's put in the wrong format, right? Because this only takes one argument. So how could we fix this? I wonder if I can write on this thing again. I'll try it. No, it's not gonna work. So how could I fix this one right here?
Double parentheses
Yeah, double parentheses.
or parentheses bracket.
Or square brackets, yeah. I could put a square bracket right inside here. I wish I could draw on this thing. I don't know why I can't. So you could put that 6, 7, 8 as a new list, and then it'll append it. Or you could make it a tuple, and then put two more, a left paren here and a right paren here. And that would make it a tuple that you're appending to that. Okay, what's wrong with this? Of course you guys found out there's something wrong with every single one of these. What's wrong with this one, remove 10? Is it going to try to remove the index 10 or the value 10 that's in the list?
Value 10.
Value 10. And there's no value 10, right? So it gives you an error. And what is this list called if there's nothing in there? And blank list. Empty, an empty list. Empty list. So this is an empty list. Pop will take the last thing off the list. Since there's nothing in it, pop won't work. There's nothing to pop off. It's like a stack of plates. You put all the plates down, you pop the top one. Okay. So everybody's pretty clear about all this kind of stuff. All right. Cool. So you don't have anything due. Let's get to, we covered a lot yesterday. We're going to try to cover a lot today if we can. Where am I at? Okay, here we go. Today's Thursday, the 11th. Use my black pen now. Okay, today's the 11th. We're getting close to the end of class. The end of class is May 17th. So you guys have about a month. So that's not much, right? It's probably about 8 classes left, maybe, something like that. We're right on track. We're right where we want to be right now. So we're doing good. We're not behind. If it works out right, we might have a couple extra class periods that are free. And I'll leave it up to you guys what you want to cover. I did that last couple semesters, and I offered all these different things to teach, and I said, or we could just review for the exam, and everybody said, review for the exam, which is fine. So nothing due today, nothing due next Tuesday, but next Thursday you've got 2 things due. You've got the quiz and the palindrome tester, okay? And this is the palindrome tester. It's question number, whatever, 5 points something. And I think we kind of solved most of it already on Tuesday. Oh, this is fun. So Richard sent me some stuff. Let me see. This is funny. So thanks, Richard, for sending me that. That's funny. So these are some funny palindromes. So these don't look like palindromes, do they? But they're all palindromes. Mr. Owl ate my metal worm. So if you put it all together and get rid of these, ignore the spaces. So reading it backwards, Mr. O-W-L ate my metal worm. So these are all sentences. When you squish them all together, they're palindromes. Goddamn Mad Dog, that's not the way you say goddamn. There should be an N there. So you can't say I was cussing in class. Was it a bat I saw? That's a pretty good sentence. No, sir, prefer prison. That's weird. No, sir, away, a papaya war is on. This is one I've heard. Has anybody heard this? A man, a plan, a canal, Panama. That's one. That's an oldie.
Oh.
When they built the Panama Canal,
Oh.
a man had a plan.
Oh.
It's a canal, Panama. And that happens to be, somebody should look up the one that Sheldon said on Big Bang Theory. Maybe somebody could figure that out in class. War, sir, is raw. I've heard this one. Stanley Yelnats, that's just his name backwards. Evil, I did dwell. Lewd, did I live. Seems like evil and live. You see those a lot. Go hang a salami, I'm a lasagna hog.
I like the tangible non sequiturs.
So we're going to get rid of all the non-characters when we do this. and I'm going to show you how to do that today. Okay, so Richard sent me this. It was like a cartoon, and it was very funny. I had to really listen to it to figure out what the heck that guy was saying. But I went into the comments to figure these out because I was trying to write them down, and he was like speaking strangely. It was hard for me to understand. But anyway, you can test. I can send you these, and you guys can test this in your palindrome program that you write. So yeah, that's very funny. Okay, so that's due next Thursday. You're going to write a program that's going to test to see if something's a palindrome or not. Hang on. Karen, you're in? All right, good. Okay, so here's what we're going to do today. I might as well start with join right now, even though this is, let's see, should I start with this right now or not? Yeah, I think, yeah, I think that's fine. We'll do this. This is a kind of a complicated thing. But we're going to get into some more complicated things today if we can get through it all. And I have a class exercise for you guys to do. And you can just do it at your desk or you can do it in groups. So let's look at join. This is a pretty cool function, okay? It takes all the items in an iterable and joins them into one string. And a string must be specified as the separator. So it's string dot join and then the iterable. So here's an example. I have a single string, the pound sign here, dot join, and here's my iterable, which is a list, and that outputs A followed by the separator, then B followed by the separator, then C followed by. But then it doesn't put C at the very end, so it just puts them in the middle, which is pretty cool. Okay, so this is really a list comprehension. We're going to get into that more, but let me see if I can explain this next one. This is the key. This line right here is the key for your palindrome test. Let me see if I can explain this to you guys. Okay, right here. So you want to join two things, right? So I'm having an empty string dot join, and then I have my iterable, okay? And this is called a comprehension in here. We're going to learn about that today. And what it does is it's a shortcut for building a list in one line. It's a shorthand notation for building a whole list in one little line. So it sounds kind of goofy the way it's in here. So this is empty string. Okay, dot join, and then we have our iterable. And we're making the iterable here. We're saying E for, and let me make my string up here. Okay, there's my string. So I have my variable, it's just called string, and it's a big, long, goofy thing. So it says special, it's in double quotes, special, space, $, pound sign, we don't have to put all of it. Exclamation point, some characters and some numbers. We'll just say car, and we'll put some blanks there. Okay, there's my string, okay? E for E in string if, now we're saying if E dot is alphanumeric. Okay? So what this is saying is, remember alpha, if I said this is a method. If I said $, dot is alnum, this is a method that works on a string and returns true or false. So alphanumeric means numbers or letters. So what is this going to return? True or false?
False.
False, right. How about if I say lowercase e dot is alnumeric? What does this return?
True.
True, yeah. So it's using this alphanumeric method. So it's saying, okay, I'm gonna put e here for e, and this is our looping variable. For e in the string, if it's alphanumeric. If that's true, I'm gonna put e here. So let's build up the list right now. This is gonna spit out, is S alphanumeric? Yeah. Is P, so this whole word is going to be fine. It's going to print out special, right? And this is going to be, actually this is going to be a string, my bad. This is going to be a string. It's going to be special, is a space alphanumeric. Is alnumeric a space? That's going to return false, right? So this is only going to return things that are true. So we get rid of the space. All three of these are not alphanumeric. We're going to get rid of these two spaces, and then we're going to say C-H-A-R. Okay? So this little line here removes everything that is not a letter or a number. Okay? So in your palindrome tester, you're going to write something similar to this, but you're not going to use alphanumeric because you're just looking at strings. So what's the one that just checks for strings? Letters. You guys remember? It's close to this. Is, anybody remember? Is alpha. Is alpha, yeah. So you're going to replace is alpha here. And that will just return only things, like if I had a number in here, like if I had the number 2 here, this would actually, the way this is written, it would keep the 2. But if I use is alpha instead of alnum, it would get rid of the 2 and it would just keep all letters. Okay? So that's how you're going to crunch those palindromes together. Okay? And then we had a method that we came up with yesterday that was a pretty cool method. He's not here today. To reverse the string and then compare each one. All right, so this, I know this is kind of a lot to take in right now, but this is a really cool, we're going to get more into list comprehensions later in the class, but does this kind of make sense to you guys?
Okay, but what does the E for E mean? Like what? Why? I'm confused.
It's just a variable.
Oh.
This could be anything.
Okay.
This could be x. X for x in string if x dot is alpha.
Okay.
This is just a variable.
Okay.
Okay. So the way we would write this, the long way, is we would say, we could say something like for, we could do it like this, for E in string, remember this gets each character, right?
Yeah.
And then we could say, first of all, we could say new string is empty before here, make it an empty string. And then we could say an indentation, we could say if E dot is alpha, then we could say new string, 2 indents now, plus equals E. So this would be building up. So it's checking each letter. Is it an alpha? Yes. So it's adding E, which is for E in string. So the first time E is S. Boop, 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 boop. So it just keeps going. So these 4 lines are equivalent to this right here. If that makes sense. This is a little bit cleaner and more concise to write. It's a little more elegant. And if you're going to be a Python programmer, you need to know what a list comprehension is. Okay. So any more questions about that? That was kind of, we jumped in kind of heavy, but we're going to go back to some lighter things here. No more questions about those comprehensions? Guys got it? Alessandra, you following it? Yeah. All right. So passing lists to functions. So here's a function. We call it modify elements. And we're passing it a list items. And you just pass a list in just like normal. It's just when you write the function, if you're defining it right here. I didn't really write the whole function here, but this is the argument now. Items is a list that you can multiply by 2 for each item. Okay, so we could just write a little function here called def, what do they call it? Modify elements. Modify elements, and it takes a list, and we can just call it, what do I call it there? Oh, we call it items, okay. So we're defining a function, and then inside here we can say, and this is going to be a list, say. It might be numbers. Say it's 1, 2, 3. So we could say something like, we could do it the long way instead of a comprehension. We could say for I in items, and then 2, we could say items, let's see, oh no, that's not right. This is going to give me, the numbers. That's going to give me the elements of that. I want for I in range, length of items. This is going to give me the indices. Okay. Items sub I equals items sub I squared. Okay. So this is my whole, and then at the very end, right over here, one indent, I could just say return items. Okay. So if I made a function call, I could say, let's see, I could just say new. I use new list. I could say new numbers, whatever. Or let's see, I'll say squared numbers. Equals modify elements. I'm calling a function. And I'm passing in numbers. Right? So that's 1, 2, and 3. So if I printed out squared numbers, it would be 1 squared is 1, 2 squared is 4, 3 times 3 is 9. So it would give me this list. So I'm passing a list into a function. Does that make sense? So you can just pass lists right into functions. And let's jump down. You can pass a tuple into a function the same way. Okay, if we had a tuple, if we had a tuple up here, my tuple, I'll just say my tuple equals, this will be 1, 2, and 3 like this. We could pass my tuple in here as well, okay? But, let's see here. You can't modify a tuple, right? So, this second line would not work here if passing in a tuple, because you're actually trying to modify. You're saying item sub I is item sub I squared. So item sub I would be 1. You can't modify a tuple, so we'd have to create a new tuple or a list inside here. We could just create a new list. Whoa, jeez. These things dry out quick. Let's try this. Foil. Let's try red. So if I was going to write this for a tuple, okay, that's better. So I would say mod. Let me see. I'll call it mod tuple. Mod tup with tuple here, and then I would say for I in range, I could do the same thing. Length of tuple. So this is going to give me the indices, because this is index 0, 1, and 2. Right. Then I could build up a new list right here. I could say, let's see, I should have said new list here, a blank list. This is 2. Then I would say new list, sub I, or no, you'd have to say dot append, sorry, dot append, I. If you have a blank list, you've got to append things to it. And then, so you'd just be appending, and then at the end you would just say return new list. Okay. So this isn't modifying the tuple, because you can't. It's just going to use the tuple. Append I squared. There we go. So that's how you'd have to change it up for a tuple, because you can't modify a tuple. Okay? Does that make sense? You know you can't go and modify a tuple. All right, so sorting a list. This is where it gets really nice and easy in Python. Are you still there? Keep waiting. Don't allow. Okay. Hang on. Did I lose my call? Oh no, I've got everybody here. Is there still anybody trying to get in? All right. Let's take a peek at sorting. Oh, here we go. Anthony. All right. Let's take a peek at how easy it is to sort. All right, let's make this bigger. All right, cool. Let's start at Python here. Let's make this full size. All right. Okay, we'll start at Python interactive. We'll call it numbers equals. Can somebody read me out those numbers up there? What are the unsorted ones?
What?
1? Is it up there? Sorry. Oh, I'm not. I lost the window. We'll invent it. Let's say 8. We're gonna go 1 to 10. 1, 3, 5, 9. We'll go to 9. 4, 7, 6, 2. Did I get them all?
You mean 10?
Is that 1 through 9?
Oh, yeah. Okay.
Yeah.
Yeah.
Okay, that looks pretty good. All right, so there's our numbers, and it's not sorted. all we gotta do to sort this is say numbers dot sort, call the method. And that sorts it in place. And now if I type numbers, everything is sorted. So that's pretty cool, right? This numbers dot, and it's a method because it's a dot followed by, so this is an iterable with a method with the numbers. And it just sorted, it sorted the thing in place, which is pretty cool. Okay, so if we want to do, so this is this line right here, we just did this. And if we want to do a reverse sort, okay, we say numbers dot sort reverse equals true. So let's try that. Whoops, one minute. Okay, so we got numbers now, and it's sorted numerically in ascending order. But now we can say numbers dot sort reverse equals true. So this should sort it in reverse numerical order, which it did. So now it's 9A. First it was unsorted. Then we sorted it. And then we did a reverse sort, which was pretty nice. So now it's just reverse sorted. And it actually just changes the list itself. You don't have to assign it to a new list. So there's a lot of really cool little functions that we could use. Built-in function sorted returns a new list. Oh, okay, that's right. If you want to return a new list, you use sorted. Sorted instead of sorted. So let's say x equals numbers dot sorted. Is that right? Or maybe it's sorted numbers. I can't remember this. Yeah. Okay. Because we had it numerically sorted, or reverse numerical. Now it's.
What was different about that in numbers dot sort?
Numbers dot sort sorts, so we have x now and we have numbers. What numbers? If you use dot sort, it actually just changes the list itself that you gave it. But if you use sorted, it returns a new list. It doesn't change the argument you passed to it. Does that make sense?
Almost.
Let's try something simple. Say x equals 1, 2, 3, and we'll say y. So watch this now. So let's reverse sort x. So we'll say x dot sort reverse equals true. So that's reverse sorts x. So x is now reverse sorted. But I could say y equals sorted x. So this returns a new list and sets y equal to it. And it sorts it at the same time.
Okay, that second one is reassigned?
Yeah, so x is still what it was, but now y is x sorted.
Oh. Okay, a new list, that's what you mean by new list. Now
Yeah,
it's,
yeah.
that's what y is the new list.
So
Sorry.
return, yeah,
Thank you.
sorted returns a new list. Let me say, let's say x equals sorted numbers, okay? All right. Save this, okay, so we're doing well. So how about searching sequences? We want to search for a number. And a sequence could be three things. Who can tell me? We've been talking about lists and tuples, so what's the third thing that's a sequence? There's one more thing.
Like as a data structure?
Nope, it's even simpler than that. What is this thing?
Oh, string.
A string is a sequence of letters.
Mhm.
Okay, so there's three things. So if I want to search a sequence, we've got a couple ways to do it. We already did the numbers.index 5. So if I wanted to search for, oh, what is that? My computer's been like flashing for some reason. Probably means my monitor's going out. So if I had this, string here, well, no, that's not a good example. Where's my, this one right here. If I said numbers, if I said numbers.index and I passed it 2, what would that return?
1. Index 1.
Remember, index, it's not returning the index, it's seeing if 2
This
is,
the list
well, it
of
is,
there.
yeah, you're right, my bad. So it is gonna return 1 in this
It's
case.
gonna return one.
Right, you're right. So if it returns a value error, it means it wasn't found. So this is one way to search a list, okay? This is one method, okay? We could use that. You could also pass a second argument to index. We could say, what's numbers, where's my red pen? Here. Thought the red was the best, there you go. What if I said numbers dot index 2 starting at 1? Okay. So we're looking for 2 in this right here, and 2 is there, and I'm starting at index 1. Okay, and going to the end. So you can tell it where to start searching. That's what this second argument is. So this would be our search value, and this would be our starting index. Okay, so that's where we're starting. So here's an example on the board here. Numbers.index. We're looking for 5 in the numbers list, which is up here. And we're starting at index 7 in this case. Okay? Value 5 starting at index 7 and going to the end. Okay? So index 7, 0, 1, 2, 3, 4, 5, 6, 7. Oh, it is going to find it. It's going to find it right here, and it's going to return 8 because that's the index. Okay. There's a couple other operators that are real nice, in and not in. Okay. So we could say over here, we got numbers 1, 2, and 3. We could say if 1 in numbers, print indent true, whatever, right? So there's in and then there's not in. Okay, which is just the reverse. So let's take a peek at that. Let's try it. So we're now right here. Okay. So we got X, right? It's 3, 2, and 1. Let's see if 2 in X. Okay, so that is true. How about 5 in X? What's that going to do? False. False, yeah. So this is a way to see if there's a number in the list. How about, does it work with strings? Let's see. Let's see, my string equals cat. Okay. can we say A in my string? Oh, what'd I do wrong?
Oh, yeah.
Need to do that. So you can do it with a string too. You just had to make that a string, okay? How about, let's look at the not in. Let's say, is Z in my string? No. How about Z not in? Yeah. So my string is cat, but cat does not have a Z, so not in is true, right? My string is cat, it doesn't have a Z, so Z not. So you can use in and not in to search. Strings, sequences, tuples, let's make a tuple too. My tuple equals, let's see, 1, we'll put cat, the string cat in here, and we'll put 2.35. Okay, so there's a tuple. Now we can say, is 1 in my tuple? Whoops, spelled it wrong. That's true, okay. How about, is 2 in my tuple? Then I can use an integer. False, 2's not there. What about 2.35? That's true, it is in there, okay? So in and not in are pretty nice little operators. And then there's any and all. 2 more little terms you can use, okay? So it means it's true if any item in an iterable is true for any, and all if all the items are true, okay? So we can say, let's say any, did I have an example here? My string, okay, so basically it's looking for, if we just say any my tuple, it's true because my tuple has values in it, okay? It's basically checking if there's any values. Let's create an empty tuple. And then we'll say any empty tuple. And this should be false because there's nothing in it. Okay. And all my tuples should also be false. What does all do again? All the items are true, okay. So let's create a tuple with, let's say empty tuple. It's not good. Now it's gonna have something in here. I should be able to augment it, right, with another tuple. Now it has something in it. 1, 2, and 3. Now let's try all. See if that does. And that's true. That's right. And any should also return true because it's not empty. I'm not exactly sure what all is telling us here. All the items are true, or if any is true. Okay, what time do we have? All right. Let's take a little break. And let me see, I want to give you guys something to do, the class exercise when you come back from the break. Let's see, I'm gonna move this down. You can do this at your desks and I'll come by. So here's what I want you guys to do. You can take a break and then come back and do this, or do it during your break. So create a list called numbers containing the values from 1 through 15. Okay? Then I want you to use slices to perform the following operations consecutively. So first select the numbers even integers. Then replace the elements at indices 5 through 9 with zeros. Then show the resulting list. Then keep only the first 5 elements. Okay? So you're going to be deleting everything from 5 or 6 on. And then delete all the remaining elements by assigning to a slice. Show the resulting list. Okay, so you're just going to be working through this whole thing. If you took notes on Tuesday, you should have everything to do this. Okay? Yeah. So you could even create this numbers using the thing I showed you earlier. Instead of typing up numbers and putting in 1 through 15, you could use something like numbers equals list range something to something. Okay, I'm giving you a hint right there. You can create your starting thing with 15 with that command. Okay. So yeah, come back at 10 till, and then we'll look at this, and then we'll get more into list comprehensions. And you guys remember slices were things like a slice was a part of a list, right? So it would be something like numbers 0 to 2. This would be a slice, right? And then there's also a step. There's a third one right here, which is a step. And you guys might remember there, if you put a 2 in there, it does something, and if you put a -1 in there, it does something else. And I forgot my water bottle again. Bring that. I refuse to go buy soda pop or water here, it's too expensive. It's like $2.95 or something for a little can.
Yeah, free stuff, but it tastes pretty bad.